I'll click the DataReaders button on our sample, which brings up a form that allows us to try a bunch of different examples, different ways to work with the DataReader class. The first one shows off techniques you've already seen, just for comparison here. We'll create our connection and our command, open the connection, execute the reader, and here, just like before, we'll use a string that identifies the name of the field to index into the collection of fields and get values out as object from that data reader. This is the slowest possible technique, both because we have to look up the field each time for each row, given the name, find its position, get its value, and because it's returning an object back, and should you want to actually work with that object, you'd have to cast it to the correct type of thing so you can interact with it in your code. Obviously, we know the results here. We get back the category ID and the category name. Fine. The next example does it a little smarter. In this case, we set things up just the same, but when we come to retrieve the data, we do it by specifying the ordinal position, the actual position within the collection of columns. This is a little faster because it doesn't need to look up the position of the field within the collection of fields. On the other hand, since I'm single-stepping through code, who the heck cares? But in your applications, if you're iterating through rows very quickly, you might want to do it this way to save some time. On the other hand, think how brittle this makes your code. Should you change the columns that you're retrieving, or add a column or reorder the columns, this code breaks. So if you're going to do it this way, you might want to create a constant that refers to the position of the column within the collection so that you could just change that constant if you change the fields you're retrieving. But I think the next example shows even a better way to solve the problem. That is, there's our results. The better way might be to call a method of the data reader which looks up for you the position within the list of columns where a given field sits. The getOrdinal method returns back the position given the column name. This way, you have the best of both worlds. You can use the column name to identify the field you want, but you don't pay the price of performing that lookup for each iteration through. Instead, you perform the lookup once before you start iterating through the rows, and then once you're iterating through the rows, you use the variable in which you've stored that position to index into the set of columns. This really is a better solution. Now remember, we're still returning objects back here. So you need to, if you want to work with them as specific types, we'll need to cast them somehow. And our next example will show that off. But if you just want the fastest way to retrieve the individual columns, I think this wins. There's our results. Now you might want to work with the values in a data reader using specific types. You can do that using the various here, for example, we're using getString and getInt32 as methods that return values from our data. Now, I somehow managed to name these variables not very well, but you'll see we have first the ordinals for the columns, and I have customer name. It's not a customer name. It is a product name or category name, but we'll let that go for now. We've got a variable in which to put the category, and while we read through this, we're going to retrieve the category name as a string. There's one problem. The getString method will raise an exception if the value it's trying to retrieve is null. So we need to check to make sure it's not null first. The isDBNull method will do that for us. We'll check to make sure it's not null and then call the getString method. Adds a little overhead, but it's required if we want to cast it as the right type. Now remember, the DBNull type is different than the C# null value, and so you can't just compare it to null. It's not null. Null is a zero pointer. We have a specific null value in a database, and that's what we're checking for. Here we're checking if reader.isDBNull. If that's not true for this column, then we can retrieve the value as a string. No need to cast it. They'll do it for us. We'll repeat that for the ID column. This one can't be null. It's the primary key, so there's no reason to check to see if this one's null or not. We'll just call the getInt32 method to return back the value as an int32. And of course, I'm not really using them as strongly typed values, I'm just displaying them in a string. Your code, however, might need them to be strongly typed values, and this would then be a benefit to you, calling these methods and there are other methods like them for other data types. When we're done, we display the results, and you're not surprised. There is another technique for retrieving data from a reader, and this involves, I'm skipping fast because nothing's new in our code so far, and that involves retrieving all the columns at once. Here, I've created an array of objects named all fields, and I've set the size to be, well, big enough for the fields we have. While we read through rows in our data reader, we'll just suck all the columns out at once into our array of objects. No worrying about what position they're in, not their names, nothing. They're just in our array of objects. Now at this point, since they're in an array of objects, the only way to refer to them is by their index within the array. So we need to use those ordinal values we already calculated higher up in the code, here, to know where to look for the specific values. Given those, we can retrieve fields from the array of fields. We're done with the reader for this row. We're getting values out of the array instead. If you have a lot of columns, this is a great way to do it. Get them all sucked out into your array, and then do whatever work you have to do within that array, letting the reader go on to the next row when it's ready. Here, of course, we get the same exact results, using a slightly different technique, which retrieved all the data at once from our reader.